Andrew Hopkins.
Good afternoon. This is my senior research project on a study of material type in Chladni plates. First, a little about me. My name is Andrew Hopkins. I attend Magna Vista High School, and I plan to attend Virginia Tech and do the Corps Cadet program and major in music. So a little bit about why I chose this topic. I chose it because I enjoy music and I plan to major in it, and I enjoy making music and listening to sounds and working with audio equipment and things of that nature. And a bit about why this topic is important. It's important because it could affect anything at all that deals with vibrations, especially if there's one material that is larger that vibrates a bunch of smaller materials. So firstly, what are sound waves? They're simply air molecules that vibrate around in the air, and they travel in waves that contain amplitudes and phases. And sound can come from just talking, making friction, or vibrating something, or shaking it. And what exactly are vibrations? The word vibration can simply be defined as the jiggling or oscillation of particles in a method that result in a shaking motion. And it constantly happens, and it can have many effects, such as causing weathering and erosion and affecting sounds, and helping to just break things down quickly. So for my equipment for this experiment, I had to have an amplifier, a speaker, and a tone generator. I needed an amplifier because larger speakers need an amplifier to work at their rated frequencies, and this can be hard to achieve from just a headphone jack output. And the amplifier also would convert the output of my headphone jack into a speaker wire output, which allowed me to easily connect to any speaker I could buy online. And I needed a speaker to actually cause the vibrations. So the way a speaker works is it has a magnet and a coil and a cone. So the cone is the larger part of the speaker. It's usually made out of paper, and it's attached to the coil. And when you send power to the coil, it becomes an electromagnet that is attracted to the magnet below it, and this causes a vibration. And doing this several times over a second will produce a sound wave. I also needed a tone generator, and for this I used the Desmos graphing calculator, because you can go into the graphing calculator and type the word tone and parentheses, and in the parentheses you can type out the exact frequency you would like to be played, and it will play it, and it will do multiple of these frequencies at once. So for my materials, I had two main groups of metal and plastic. The metal group contains steel, aluminum, and copper. The steel and aluminum are more construction materials, and the copper is often used in electrical work. And then the three plastic groups, the PLA, PETG, and ABS, these three were chosen due to how easy it would be able to get and turn these into the 8x8 sheet that I would use in the experiment, which was done by the 3D printer that I have at home. So what are cymatics? Cymatics is the study of sound and how the vibrations from it can be visualized. It has many uses. It has been used to clean solar panels, and there's also a more popular music video where one experimentalist named Nigel Stanford used it in many different forms, such as the Chladni plate, which is what I used, and a Rubens tube, which is a tube that if you have fire going through the tube and you play sound in the other end of the tube, and you have several small holes drilled in the top, the fire will come through the tube, the holes at the top, in the shape of a wave. So you can actually see the wave that the sound is making. And this was used in one of his music videos along with some other devices as well. This leads me into my research question. Does changing the material of the plate in a Chladni plate system affect the effectiveness of the system? So my hypothesis states if I change the material in the Chladni plate system, then it will affect the image or visualization created by the plate. My null hypothesis states that all of the means are the same or very similar, and my alternative hypothesis states that at least one mean would have to be different in order to show a difference in the image. So my variables would be the plate material, which is my independent variable because I changed it, and the image is the dependent variable because it depends on the plate material in this experiment. The frequency was controlled in this experiment, however, it could be changed in order to produce a different image if you would so like. So for my method, I first started with the speaker and I cut a small hole in the middle of the speaker. And then I took a threaded rod and glued it into the speaker. And I then took all 6 plates I had and drilled a hole in the middle of each of them in the center. And I used 2 nuts to attach the plate to the threaded rod. Then I took the wires from this and ran the wire from the positive on the speaker to the positive output on the amplifier, and the same for the negative. After this, I connected my laptop to the amplifier and made sure everything still worked and it all vibrated, and it did. So then I took salt, which was my choice of fine medium for this because of how easy it was to get. You could also use another medium such as sand or glass silicate. So I tested it and made sure it made the image, and then I used my camera on a tripod to take a picture of each visualization after I let the tone play for a couple seconds with each plate. And I did that for each plate 30 times, so I'd have normality in my groups. After that, I took all 30 images and overlaid them and used a program that would then again take each image and separately overlay it and count each pixel that is the same in each image to give me an overlap percentage to tell me how much of the same, how similar the image is to the average image. So for my hypothesis testing, I used a one-way ANOVA, which is an analysis of variance to determine if there's a variance in the means. And then I checked all my conditions, which were random, normal, independent, and then I made sure they had similar variance. For my results, I ran the test and then graphed all the information. The X in each little box on the box and whisker plot represents the mean for that group. So, which leads me into my test statistic, which was an F value of 0.601. And the F-test statistic is a measure of the variance with a higher number, meaning that the variation is more equal between the groups. For my p-value, which was 0.699, this means that if one of the true means for the overlap percentages for each group is different, then there's a 70% chance that I would get that it was different purely by chance. For my discussion, there is not evidence at the 0.05 level of significance to conclude that one of the means for each of the groups is different. If there was any error in my statistics, it would be a type 2 error, which would mean I got that none of the groups were different when one actually was, but that was not the case. And then for my limitations, I would have liked to have had the speaker mounted to something like a sturdy table instead of on the floor, because if I had put it on a weak table, the table itself could have vibrated and that might have affected my results. But the speaker could have vibrated around on the floor. So if it was mounted to a sturdy table that was, say, bolted down, then my results could be even more accurate. My amplifier, since I had the volume on my laptop and the amplifier turned up, it introduced a little bit of distortion into the waveforms, which could have affected it. And then for the glue I used, originally I just used a little bit of hot glue around the threaded rod to hold it to the speaker. And when I first tested it, the glue actually broke. So I re-hot glued it, and then I also used some wood glue, which ended up holding it in place and making sure my results were accurate. I would like to thank the audience and judges for listening to my presentation, and I would now answer any questions.
Can you tell me a little bit about the why? Like, how does this apply to all of us in general? Why is it important for us to think about this?
So this could apply to just using different materials in building things. So if you know something's gonna vibrate and you want, if there was any difference in any of the materials that you'd used that, were caused by the material, so if the image was different because of the material, you would wanna know that before you went in to build something, in case that would affect whatever you were building.
So since we're talking about shaking, I automatically think about earthquakes. So how could this help engineers and contractors selecting the correct materials in earthquake-prone areas?
So it'd be the same thing with, Ms. Hatchett's question. The material, whether it was, I would say more sturdy, that might would have affected it if, well, that might would have been shown if the sturdiness of the material would affect how the image was created because of the vibration. But because of the vibration not showing any difference for each material, I would say that the means of using each material would be about the same